Hello and welcome to Belmonte Math. This is an introductory lesson on solving the equations like the ones you see on your screen. Whenever you're asked to solve an equation, you have to find the value for the variable, in this case x, but it can be any letter, that makes the equation true. So in the first example here, you're trying to find a number, 4x, that when you multiply it by 3, you're going to get 12. Before we start, however, I want to explain a few terms. Whenever you have an equation, you're always going to have a letter, which is called a variable, and a constant. In this case, the constant is 12. The number in front of the x that you're multiplying x by, which in this case it's a 3, is called the coefficient of x. In order to solve this equation, the idea is to get the x on one side of the equation by itself and then get the constant on the other side. Whenever I solve these equations, I like to get the x's on the left-hand side. In this first example, you can see that that's already the case. We have the term with the variable 3x on the left-hand side and the constant 12 on the right-hand side. Since we know what 3 times x is equal to, what we need to do to solve this equation is determine what 1 times x is equal to. Since this is 3 times x, the opposite operation to multiplying is dividing, so we divide the left side of this equation by the coefficient of x, which is 3. But as soon as we do that, we must divide the right side by 3. Whenever you're solving equations, remember what I like to refer to as the golden rule of solving the equations. Whatever you do to one side of the equation, you must do to the other side of the equation in order to keep the equation balanced or true. So now that we have 3x divided by 3 equals 12 divided by 3, we can divide the two 3's, the one in front of the x and the one below it, the numerator and denominator. Each of them becomes 1, so we end up with 1x over 1, or x, equals 12 divided by 3, which is 4. If we go into this next equation, 3x plus 7 equals 19, you will see that we have the constant 7 on the left side with the x. So what we have to try to do is isolate the x, or get it by itself on the left side, which means that somehow we have to remove the plus 7. In order to make it 0, what we need to do is subtract 7 from the left side. But as soon as we do that, we must subtract 7 from the right side. So we end up with 3x plus 7 minus 7 equals 19 minus 7. On the left side, 3x plus 7 minus 7 is 3x, and on the right side, 19 minus 7 is 12. So we end up with 3x equals 12. You'll notice that this is exactly the same as equation number 1. I did this on purpose to show you that no matter what equation you start with, if you simplify it, you will eventually end up with a variable term on one side and the constant on the other. Now, in this case, we have 3x equals 12, so what we need to do is exactly what we did before, divide both sides by 3, and we end up with the equation x equals 4. As we look at this third equation, you'll notice that we have a variable term on each side of the equation as well as a constant term. Again, because I like to get the variables on the left side, what I will do is remove the positive 5 from the left side. In order to do that, I have to subtract 5 from both sides of this equation. So on the left, you have 7x plus 5 minus 5, and on the right, 4x plus 17 minus 5. So on the left side, we're left with 7x because the plus 5 and minus 5 become 0. On the right side, the 4x plus 17 minus 5 becomes 4x plus 12. I want to remove the 4x from the right side so that I will have all the x's on the left. So I have to subtract 4x from the right side, and as soon as I do that, I have to subtract 4x from the left side. So on the left side, we end up with 7x minus 4x, which is 3x, and on the right side, 4x minus 4x, which is 0, and then plus 12. This equation is again exactly the same as the ones we ended up with in the first and second examples. So we just divide both sides by 3, and we end up with x equals 4 in the very same way as we did it before. I did this again just to show you that once you've done proper mathematical steps, you'll end up with one variable on one side of the equal sign and a constant on the other side. Solving equations means finding the value for the variable that makes the original equation true. So if you want to do an informal check of your answers here, you substitute the x equals 4 into the left side of the first equation. You get 3 times 4, which is 12. When you compare that to the right side, you'll see that they are equal, and that confirms that your answer is correct. In question number 2, again, you substitute x equals 4 into the left side. You multiply it by 3, which gives you 12, and then you add 7, which gives you 19, which again is equal to the right side, which confirms that the answer x equals 4 is correct. In example number 3, you have to substitute x into both sides of the equation, so you do it one side at a time. On the left side, substitute x equals 4. You get 7 times 4, which is 28. You add 5, you get 33. On the right side, you substitute x equals 4. Multiply it by 4, you get 4 times 4, which is 16. You add 17, which is 33, and since the two sides are equal, again you have the correct answer to the equation. Now I've removed all of the red marks to show you what these solutions should look like when you're finished. You'll notice that they're presented in a logical sequential way with all of the equal signs, one above the other. It's very important that you present these solutions in a way that's easy to follow. It's time for you to try some of these on your own, because that's the only way that you're going to learn how to do them. You can pause the video now and try the equations that are on the screen, and then restart the video, and you can compare your solutions to the ones that I have done for you. These are very similar to the ones we just did. In the first equation, you have 5x equals negative 15. In order to get the 1x, you have to divide both sides by the coefficient of x, which is 5. So you end up with 5x over 5 equals negative 15 over 5, or x equals negative 3. In the second equation, we have 8x plus 7 equals 31. In order to leave the x on the left side by itself, we have to eliminate the plus 7. To do that, we subtract 7 from both sides. We end up with 8x plus 7 minus 7, or 8x, equals 31 minus 7, or 24. To get 1x on the left, you divide both sides by the coefficient of x, which is 8. So we end up with 8x over 8 equals 24 over 8, or x equals 3. The third equation has a variable on each side and a constant. So we start by eliminating the constant on the left side. We have 3x minus 4. To eliminate the minus 4 or negative 4, we add 4 to both sides of this equation. So we end up with 3x minus 4 plus 4 equals x plus 12 plus 4. So on the left, minus 4 plus 4 is 0. We end up with 3x. And on the right side, x plus 16. Now we want to get all the x's on the left side, so we have to eliminate the x from the right side. In order to do that, we subtract x from both sides of this equation. But when we do it from the right side, we have to do it from the left side. So we have 3x minus x equals x minus x plus 16. On the left side, the 3x minus x is 2x, and on the right side, x minus x is 0, so we're left with 16. To get 1x on the left side, we divide both sides by the coefficient of x, which is 2. 2x over 2 equals 16 over 2, or x equals 8. We're finished these equations, and you can see that they're very similar to the ones we've done before. Just perform the operations and you'll be fine. I've removed all of the red marks to show you what these equations should look like when you're all finished. They're presented in a logical way that's easy to follow. Math is not just about getting the answer to a problem. It's about learning how to analyze a problem, applying your knowledge to solve the problem, and then writing the solution in a way that's easily understood by others, which is a very important skill to learn. I hope this was helpful. Thanks for watching.